Let's try to understand how a vision transformer works. A vision transformer helps you perform image classification. So the very first step is called patching, where you split the images into non-overlapping patches. So here this image is split into 3 by 3, which is total 9 patches. In the next step, you pass the patched images into the vision transformer architecture. And in this architecture, the very first step is called as embedding. So there is an embedding block in the vision transformer architecture where each patch is converted into corresponding vector representation. So this is the first patch converted, second patch converted, and then this is the last patch converted. But in addition to these vector representations, you also see an extra token here, which is the classification token. So it is appended at the very beginning of these set of tokens. Then after this, you add position embedding, and this position embedding tells that the classification token is at the 0th position, this is at the position number 1, and then the last patch is the position number final. And this position embedding vector is like a learnable parameter in the neural network training process. Then once the position embedding is added to the original token embedding, you pass that representation to the transformer head. So this is the third part, which is the transformer head, where there will be multi-head attention, and there will be key, query, and value calculated. And then multi-head attention will process the input embedding vector in parts. So if there are 12 attention heads, each attention head will take care of 1 by 12th of the vector. And then finally, at the output of the multi-head attention, you concatenate all the outputs coming from each individual attention head into one single representation. Then this whole thing passes through a multi-layer perceptron, MLP, and this allows the transformer to enhance the representation capability. So you first project the representation into a higher dimensional space and then back into the original dimension. So if this was 768 dimensions per vector, in the MLP, there might be a hidden layer which can project into 3072 dimensions and then back into 768 dimensions. And then whatever output you get here, you pass into the final part, which is the classification head. So this is the fourth element or third element in the transformer architecture, which is for classification. So here, let's say you want to perform a 1000 class classification. Your 768 dimensions now need to be converted into 1000 set of nodes. So here you will have 768 nodes. Here you will have 1000 nodes, and this will be like a fully connected layer. If you wanted to do 5 class classification, here you will have only 5 nodes. So this classification head will depend on how many classes you have, and then you can perform a softmax probability distribution to finally say whether this image is that of a tulip flower, or is it a cat, or is it a Lamborghini, etc. So this is overall very nicely captured in this vision transformer architecture diagram, which was originally proposed in the vision transformer paper, which was titled "An Image is Worth 16 by 16 Words." So do check out the paper. If you want to learn more details, check out our channel.